Thank you. Okay, Ross, you're on your own.
Alrighty, let me start my recording here. So, first of all, it's awesome to be talking again with you guys and gals. Again, as Ollie said, I'm in Menlo Park, sitting in my office. So today I'm going to talk about building a software as a service platform with Node, Docker, and CoreOS. So, a little bit about me. So I'm Ross Kukulinski. I'm the founder and CEO of Yodeler. And I also am the co-organizer for Baynode, which is the Bay Area Node.js meetup. So if you're ever in the Bay Area, look me up. Love to meet you in person. I'm a huge soccer fan, or football for you. And then you can find me on the internet at Ross Kukulinski on GitHub and Twitter. And then I'm also usually lurking on a number of channels on Freenode at RossK. So today, I'm going to cover our Yodeler story, why we've gone with Docker and CoreOS, and then some tips and tricks that hopefully will allow you to avoid some of the pitfalls that we ran into getting our whole stack up and going. So just a little bit of history. So Yodeler is a browser-based communication platform that we built mostly because we got fed up with all of the other audio and video conferencing products. Our parent company, before we spun out, had been building audio and communication systems for about 25 years now. So we knew audio, and we were frustrated with everything else. So we said, what the heck, let's just build a little Node prototype using WebRTC and have a basic audio conferencing system. And that's what we did. That's what my team did. So this is built with Node, WebRTC, and we have a proprietary audio backend that allows us to scale the size of the conference way beyond a traditional peer-to-peer conference. So we've been using this product internally since about February of last year, and everything was going great. Until this internal tool wasn't internal anymore. We had some sales people that started using Yodeler as a remote marketing tool, not unlike what I'm doing right now. And we had a couple of customers that were more excited about Yodeler than they were about the flight simulator products that we were trying to sell them. So we decided to take Yodeler, spin it off in a new company, and focus on building a browser-based communication platform. The problem was we realized that this little prototype wasn't going to scale or be easy enough for us to build upon as our development team grew. So we decided to go back, re-architect, and rebuild everything from the ground up. And that meant reanalyzing our entire deployment and build systems. And as we were going through that, one of the things that we looked very carefully at is this idea of a 12-factor application. If you haven't heard of 12-factor, definitely go check it out. It's essentially a set of guidelines for building stable and scalable server applications. And so we use this extensively throughout our new architecture. Now, some of the goals that we had for our team, we're a small team, so there's only 4 of us now. But what we realized was that our monolithic app, because everything was in one place, all of our developers needed to know essentially everything about all the pieces of our system just to do development of one piece. So we decided we really wanted to split up this monolithic application into a series of microservices. And each service would do one thing and one thing well. And in the Node community, you should be familiar with that. That's the whole idea of the success of Node and NPM modules. Small modules that do one thing well. We also care very much about metrics and actually analyzing our products and our content. And so one of the issues that we had run into that we wanted to be able to run multiple instances of the same application on a given server. And our existing build system certainly did not allow us to do that. The 2 different versions of our Node app collided with each other. We also had run into a couple problems of where something would work fine in a developer workstation, but didn't work in staging or didn't work in production. And we wanted to sort of eliminate this, it works on my machine, so it's not my problem issue. And then, of course, because Yodeler is going to take off and it's going to be incredibly successful, we needed it to be scalable, we needed it to be fault tolerant, and because I'm the primary DevOps person, I wanted to minimize the amount of time that I actually had to do DevOps. So that's where Docker comes in. So a little bit of background about Docker. So I'm sure that most of you are familiar with running applications in virtual machines. That's what Rackspace and AWS and Joint, DigitalOcean, they're all virtual machines. And so when you're running an application, like on the left-hand side, your app B there on the left is actually running on an entire guest operating system, which runs on top of a hypervisor, which runs on top of the host operating system, which means that every time your application wants to open a file or listen to the network, those underlying syscalls have to go all the way through the guest operating system and then be translated to the host operating system. Docker, however, is kind of like a lightweight virtual machine. It throws away the guest operating system, and the Docker engine allows your application to talk effectively directly to the host operating system. So that is going to give your applications near bare metal performance, which is incredibly important. And like virtual machines, Docker also containerizes your applications. So app A and app B cannot talk to each other. They're not sharing a file system or anything else like that. You can, if you want, you can do networking between the two, but it's up to you and the Docker engine to allow the communication between the two. Some of the other things that Dockers bring to the table, Docker containers are able to start extremely quickly. So virtual machines might take a minute or 2 or 10 minutes to start. A Docker container will start up in less than a second, and it's really just running that single process, which, as Node, we're running single core processes. It's going to be extremely quick. Containers also have a very small footprint, so in terms of the size and the runtime environment, so you can run lots and lots of containers on a physical host. Dockerized applications can run anywhere, and in fact, the image that you build on your development workstation, you can ship that container, and it'll be exactly the same thing that's going to be running in production. Like NPM, Docker has its own registry for storing images. You can use a public registry. You can also run a private registry, which is something that we have decided to do. And then one of the more interesting things, at least for me, is the fact that Docker abstracts away your application networking from your system networking. So what that means is you can have 2 Node.js apps, each running in their own container, and each thinking that they're listening on port 3000. But in terms of the Docker networking, they're listening on different host ports. So your app doesn't need to know what actual real port or actual IP address it's listening on. It just needs to know that it's going to get traffic on port 3000. So coming back to our goals, by switching to Docker, we really check off those first 3 things. So our apps are going to become much simpler by breaking them up into smaller pieces. We can run multiple versions of the same app. And we can ditch this, or at least hopefully get away from this idea of things work on my machine, it's not my fault that it doesn't work in production. So then the next question is, how do you ship Docker containers? Obviously, you can use bash scripts. You can use things like Ansible, Puppet, and Chef. The Docker community just announced Docker Swarm, which is supposed to help with that. But we sort of did a complete analysis of the whole layout when we first started building this, gosh, about 6 months ago now. And we came across something called CoreOS. And we instantly fell in love with it. So CoreOS is a very minimal operating system that is built specifically to run Docker containers. It also has some really cool features, which on this graph is shown etcd, which I'll talk more about, but it's basically a distributed key value database that allows your entire Docker, the entire CoreOS system to talk to each other. Another cool feature about CoreOS is like Google Chrome's browser and Firefox, that automatically update themselves when there's new versions. CoreOS does the same thing. So basically, it has 2 underlying hard drives underneath the hood, and when there's a software update, it'll automatically start updating, and then the next time that host reboots, you'll get the latest and greatest version of CoreOS, which is one less thing for me to have to worry about for security patches. CoreOS runs on all the major cloud providers, so we're pretty much a rack space shop, but it also works on Amazon, DigitalOcean, Joyent, the works. And then it also runs on bare metal. So we run a staging and dev cluster on bare metal here in our office. Now, CoreOS out of the box is clustered by default. So in this graph on the right-hand side, we've got 5 CoreOS hosts that all communicate through etcd, which is this distributed key value store, which has a very simple HTTP API. So really out of the box, you can take your CoreOS cluster and distribute it across multiple high availability zones and scale up the number of systems. etcd also provides this service discovery and application scheduling through etcd and Fleet, which is a scheduler that's built on top of etcd and CoreOS. And then CoreOS is very scalable. So you can, this is directly from the CoreOS docs. On the left, you have this core etcd database service cluster, which really just provides the uptime and the sort of linking of all the machines. And then you can have a batch of worker systems that are attached to your auto-scaling group that based on your loading, you can bring up new workers or tear them down. And etcd and CoreOS will automatically handle all of the scheduling of where your applications and services end up. So by combining Docker and CoreOS, we've really covered all of the major checkboxes that we had for our new architecture, which is good. I like that. So let's talk some tips and tricks, some of the things that should help you get going. So first of all, let's talk about Dockerizing a Node.js application. So the development process is pretty much the same thing as you have now when you're running and building Node.js apps. The one caveat with Docker is you have what's called a Docker file, which is basically your set of build steps that will create a completed Docker container. So I don't want to go into all of the specifics of how Docker files work. The docs are very, very good. I do want to point out a couple of things that are specific to Node that are very, very helpful. So number one, I did a talk a couple months ago on IOJS, and I'm also on the IOJS evangelism group. So there are official IOJS builds on line number 2. And then there's also node source node systems for a variety of operating systems, which are extremely helpful. So definitely take a look at those. Another thing when it comes to building Docker containers is Docker has a cached build system. So as Docker is running through each of these lines in this Docker file, it runs each step incrementally. If the file hasn't changed, or the underlying Docker file hasn't changed, then it reuses the previous build that you've run through. So what's convenient about that is on line 11, we run add package.json to source package.json. So basically, we're copying our dev package.json file into this container image, and then we run an npm install in the container. Later on line 19, we actually add our application code. What's convenient about this is most of the time your package.json doesn't change. So every time you run a Docker build, you don't want to wait for an entire npm install. So instead, if you put the package.json and the npm install, and if you're using Bower, copy the Bower.json and Bower install, do those first, then add your source. Then every time you run a build, the only thing that's going to change is going to start on line 19, which is actually copying your updated application in. The last sort of node-specific thing, and it's not really node-specific, but Node, if you've got your uncaught exception handler that's supposed to exit the moment you have a crash, Docker containers, by default, when the process that's running in them exits, the Docker container will stop. We use SupervisorD, which is a very lightweight container or application monitoring tool, that it will automatically restart your Node app inside the container in case Node crashes. Another thing that's come out recently is something called Docker Compose. It's actually renaming and rebranding of something called Fig. This is really convenient for your dev environment. So if you are building a microservice architecture where you've got 4 or 5 or heck, even 50 different services that need to talk to each other, A Docker Compose configuration file basically explains what containers to start and what build commands to run, and more importantly, how to link them all. And so you can really just run a Docker Compose up, and it will start, in this case, it'll start your web container, it'll do a build, and then in that container it'll run node index, it'll expose port 5000, and it will link it to a Redis container that it automatically starts up. So this is very, very convenient for a dev environment. So booting CoreOS. This is probably the most frustrating part of CoreOS. So unlike any other operating system that you can just sort of go to Amazon or Rackspace and say, hey, create me one of these machines or 10 of these, there is some additional setup before you actually boot the CoreOS system that's necessary. And that basically allows the CoreOS cluster to know its name and how to talk to its other nodes. And all of that data is into this cloud config YAML file. So definitely be sure to read the manual on that. There's a really helpful tool from CoreOS on basically sanity checking your cloud config. And then I recommend using Ansible for doing provisioning of multiple CoreOS nodes. The CoreOS docs are very, very good for this. They also have provider-specific documentation. So for Rackspace and DigitalOcean and AWS. And then DigitalOcean has done an entire series of blog posts on getting started with CoreOS. A lot of that is tailored towards DigitalOcean, but I still highly recommend that blog series for anyone who's interested in playing with CoreOS. There's another very helpful tool that was written by a Node community member, Ken Perkins. He is a Rackspace developer advocate. He also works with me on the Node module called Package Cloud. Package Cloud is a cloud agnostic API for Node that allows you to talk to Rackspace and Amazon and DigitalOcean through a
Hey, Ross.
So definitely recommend taking a look at that.
Ross?
Yes?
We kind of lost you after you said that you were building this thing, package thing. Can you restart the slide, basically? Do you mind?
Shh. Not at all. I apologize about that.
No, that's okay. It's our internet, because we have like weak Wi-Fi. So yeah, sorry about that. Thank you.
No worries. Where was I? Right, so another tool to help you with booting CoreOS clusters is an awesome little NPM module called CoreOS Cluster CLI. It's written by Ken Perkins, who's a Rackspace developer advocate, and it uses Package Cloud, which is a cloud agnostic API for Node to talk to Rackspace and Amazon and DigitalOcean. So CoreOS Cluster CLI allows you to very easily bring up a whole pile of CoreOS machines all pre-configured with the cloud config taking care of it for you. Caveat, right now this is Rackspace only, but if you pester me or Ken Perkins or you want to submit a PR, it should be very easy for us to add support for Amazon and DigitalOcean and some of the other hosts. Okay, so one of the things that's big in CoreOS is this idea of service discovery. How do you get your microservices talk to each other? I don't want to dig too deep into this, but I do. This is something that when I'm hanging out in the IRC channel and people always run into problems with how to get the sidekick pattern working. This link goes to a gist that's got an example starting up a Node app that talks to Redis and how to do that sidekick pattern. So definitely check that out. The basic premise, however, is that your application, when it starts up, will write its IP and port that it's listening on, will write that data to the etcd under a certain key, so that other services can basically look in etcd and find, hey, let me find all of the database instances, and I can pick one to talk to. Then to make it easy for load balancing and some of this other things, someone whose name is Kelsey Hightower, who's from the CoreOS team, he wrote a Go system called Confd, and it basically monitors etcd changes to these key value pairs. So we use this with Nginx as an internal load balancer. So as our microservices come up, they register with etcd with their IP port, and then Confd will monitor that rewrite an Nginx configuration file based on that data, and then reload Nginx inside of the container. So that's very, very helpful to get those links done. CoreOS has got great command line tools for interacting and monitoring, but we've quickly got fed up with always having to run a command line tool to see what's actually running in our CoreOS cluster. So one of my coworkers, Jared, wrote something called Corgi, which is basically a Node and Angular web app that allows you to see all of the services that are running in your CoreOS cluster, see the machines, and see the data that's in etcd. It's open source, it's up on GitHub. Would love feedback if anybody actually tries this out and uses it with their CoreOS cluster. I also want to give a shout out to Paz. I think Luke Bond did a talk last month at London Node User Group. Paz is sort of like a configuration management services and load balancing. It's sort of like your one-stop shop for actually configuring your services and sort of automatically handling some of those rolling updates and deployments. We've just started playing with Paz this week, but I've been impressed with their work. I've been following what he's been doing since like December of this past year. So definitely check that out. The community on Paz is growing quickly. Some of the things that I want to point out, I think Kubernetes, which is what powers Google's container engine, I think Kubernetes is still very much in a beta stage, but I think that's going to be the go-to system for handling, linking together multiple containers. It does things like the rolling software updates, and it does auto-scaling of those groups very easily. So I think that's definitely something to keep a lookout for later this year. If you've ever used Heroku, you can run your own version of Heroku in your CoreOS cluster using Deis. We use this for some internal stuff. We haven't yet made the jump to using this in production, partly because of some of our network stacks for our audio and WebRTC stuff doesn't yet work in Deis. But for some of our standalone tools, that we use internally, it's great for developers to sort of do the equivalent of a git push that automatically triggers a new deployment of their app. Another thing to keep an eye out for is something called Vulkan Proxy. It's basically a replacement for this Nginx/etcd thing that we've done. Vulkan is basically a proxy that watches etcd for your services that register. It's built by the Mailgun team. They say it's still not production ready, even though they're using production. We're just starting now to experiment with it, but it's pretty cool. I do want to leave one sort of important note that etcd is a database, and you should treat it like one. So commonly, when you first bring up your first couple of CoreOS clusters, you'll have 5 machines which all have etcd running, and you put your applications and your databases all in that cluster. The problem with that is that etcd is a database, and if you're running a MongoDB or Postgres, you wouldn't run your Node apps on those servers. You're going to separate them, let the databases have their space, and that's especially true with etcd, because etcd has to handle the syncing of state across the entire cluster. So the image that's here is the recommended CoreOS deployment. Have a set of 5 or more CoreOS machines that are the core etcd systems. They can be very small micro machines, and then move all of your application content to a series of workers. And the workers aren't actually running the etcd database, they're just using the database. I fully believe that Docker and CoreOS are the future for application development and deployment. It's made our process so much easier for us to deploy multiple times a day, and it's fixed so many problems that we've had. I'm incredibly excited about CoreOS and Docker. We're building our business on top of that, and I'm advocating that you should too. That's all I've got. And I guess the last plug that I'll make is that this whole talk was done using Yodler. So I highly recommend you go to getYodler.com and try it out. I would absolutely love your feedback. Feedback from users is incredibly important, as I'm sure you all know. So thanks again for your time. I'll be listening for questions on the microphones, and I'm also in the Gitter IM channel if you want to type any questions to me. Thank you.
Thank you. Okay, so do we have any questions in the room? We can pass the microphone around and Ross can answer, or you can find Ross on Gitter and then you can ask him directly there. It's up to you. So are there any questions?
So there's a question from Luke Bond on the GitHub channel. He's asking if I could talk a little bit about persistent data services on our platform. I think what he's asking is where do we actually store our persistent data? If we're using volume mounts or fleet metadata. So we actually don't store any database content in our CoreOS cluster. We are not database experts, so we are not running them in our CoreOS cluster. We did evaluate running like Mongo or Redis in our cluster, and the fact that the CoreOS will automatically move things around based on the scheduling and whether systems are coming up and down, we quickly realized that we didn't think that CoreOS was the completely ready for running databases, distributed database in it. I think in time it will get there, but it's something that I'm a little too nervous to try out.
Does the answer? Okay. Thanks for that answer. Luke is happy. I can see him smiling. I was gonna say, how many of you guys use Docker in production? 1, 2, 3, 4, 5 hands. Okay. How many of you are thinking of using Docker between now and the end of the year? A few more hands? Many more hands? Okay. Sweet. Awesome. Ross, once again, thank you. And I think we'll close the link with the Bay Area. Thanks for being with us again. And yeah, thanks. That's it. Have a good evening.
Thank you all.
Awesome. Okay, guys, that was great. I think we should have a little break now where there's some more pizzas. So if you're hungry, go and grab yourself some slice. Thank you.